All right, let's make it this one. Okay. All right, the intermediate value theorem is going to be one that keeps coming back up. They love to put these on the AP exam. Like you'll see one almost for sure. Intermediate value theorem states that if f is a continuous function on the closed interval from a to b, and d is a number between f of a and f of b, then the intermediate value theorem guarantees that there is at least one number c between a and b, such that f of c equals d. So that's got like a lot of stuff going on, but let's think about this on a graph. Okay, so f is a continuous function on the closed interval a to b. A and b then are going to be on our x-axis. So I'm just going to put a right here and b over here, and we're going to just draw a continuous function. It really doesn't matter what that function looks like at all. It just needs to be a function, and it needs to be continuous. So it might, do something like that. Who knows? You can make it look however you want. You just can't include any holes, vertical asymptotes, or jumps because it has to be continuous. Okay, so there are some key points that we kind of need to know here. So we've got A and B right here. So if I go up here, the x-coordinate of that point would be A. And then the y-coordinate of that point would be F of A. So I'm going to mark that on my y-axis. That's F of A. Because whenever I'm evaluating a function, if I plug in that value, then the function spits out the y value. So f of whatever your x value is gives you the y value there. And so if we do sort of the same thing here for b, the x-coordinate right there at that point is b, and then f of b is what we could call our y-coordinate for that. And so, sorry about that. And f of b over here be right here on the y-axis. Okay, so does that kind of help us picture like what we're talking about on a graph? So that's our f is continuous from a to b, and it says, and d is a number between f of a and f of b. So which axis is our d going to be on? It's between f of a and f of b, which are on the y-axis. So if I have a number here between f of a and f of b, you can put it anywhere you want, just for the demonstration right here. I'm going to say it's right there, D. Anywhere between f of a and f of b. So if I kind of like draw myself out a dotted line right here at D, if I start off out over here at f of a, and I go over here, down here to f of b, is it possible for me to get from here to here without crossing that dotted line? It is not. Not if f is continuous. If f is discontinuous, maybe there could be a jump in the graph where I skip it, right? But as long as f is continuous, then I've got to cross that line, right? So what the intermediate value theorem is telling us is that there has to be a point right here, at least one, although it could be more than one, because your graph could like be a sine graph that goes back and forth a bunch of times, right? There has to be a point here where there's some number c right here where f of c equals d. At least one. There could be more than one, but You have to go through that point. If you're thinking about, let's say that after gaining a little bit of weight over the winter, that Jeremy goes on the diet and he goes backwards, right? If he starts off at 204 up here and he wants to get back down to 193 where he started, he's got to pass 200, right? So, like, he's got to go past 200 in that case. That's what it's telling you here. Basically, it's just saying if I start off at a lower number and go to the higher number, I got to cross all those numbers in between it whenever I'm dealing with a continuous function. So it's a very simple idea for this. So let's look at the type of the questions that you're going to be asked for these types of things. This is actually a special case of the intermediate value theorem that has a name called Rolle's theorem that is specifically used for zeros. However, it's a special case of the intermediate value theorem, which means we could just explain it using the intermediate value theorem, which means that I'm not going to teach you another special case for us to have to learn, like memorize one more thing, right? Because on the AP exam, if they give us this function, we can just use intermediate value theorem. So that is going to be the way that we'll approach these. If you see something that says Rolle's theorem, R-O-L-L-E, it's a version of intermediate value theorem. You don't have to use that. You could use intermediate value theorem instead. And I think it's just more simple for us to just have one way of dealing with it. So I want to know if this function has at least one zero on the interval from -1 to 2. Okay, let's look at it on Desmos. This would be a calculator inactive problem, but especially when we're just starting to learn this, I think it is helpful to look at it to picture what's going on here. So what we got, e to the 2x minus 5. So e okay. So, and I am looking from x equals -1 to x equals 2. I'm looking from here to here on my x-axis. I can see right here, yes, I definitely crossed the x-axis, right? So I should get a yes for this. The idea that we're thinking about is that over here at -1, my y-coordinate is -4.866. Over here at 2, it might even be hard for us to see. There we go. I think we can. Over here at 2, my y-coordinate is 49.59 something, right? If I go from -4 to 49, what do I have to cross? 0. There could be a lot of answers to that, right? But the one that matters for this question is I got to cross 0, which means that I've got to have a 0 right here on this function. So let's look at how to do this without a calculator, because you won't be able to graph these. So when you're given something like this, the first thing you need to state is that f of x is continuous. In this case, you could say on the interval, or you could say for all real numbers. How do I know? What? Like without a calculator, how do I know that's continuous? Exponentials are just always continuous. So, because f is an exponential function. And it would be fine there, instead of saying for all real numbers, you could say on the interval from -1 to 2, because that is also true there. But multiple choice, you can get away with it. You don't necessarily have to state continuity. Free response, which is where these show up a lot, you have to state continuity. Because if this is not continuous, we don't know that it has a 0. It might jump across the line from down here to up here, right? So you have to state continuity. Then what we want to do is we want to say f of negative 1. We just want to plug in negative 1. And that's going to be e to the 2 times negative 1 minus 5, which will be e to the negative 2 minus 5. And we don't have a calculator. So we got to at least get an estimate. I need to know whether this is above or below 0. I don't necessarily need to know its exact value, but I need to know whether it's above or below 0. E to the negative 2, how could I rewrite that so I wouldn't have those negative exponents? 1 over e to the second minus 5. Now if I take 1 and I divide it by, If I take e to the 1 and divide it by e to the second, which is like 2.718 to the second, give me a ballpark for that number. What's it going to be close to? Or between? If I've got 1 divided by 2.7, that's already less than 1. Right? If I square that bottom, it's even less than that. But is it below 0? It is not. So what I got right here is small decimal number, right? I don't know exactly what it is, but I got a small decimal number. And then I'm subtracting 5. So when I take a small decimal number and I subtract 5, what am I going to get? Positive or negative? Negative. So I don't know exactly what this is, but it is less than 0. Okay? And then I want to do the same thing for f of 2. So I will have e to the 2 times 2 minus 5, which is e to the 4th minus 5. So once again, you're not going, without a calculator, you're not going to get this number exactly. But you've got e to the 4th power, 2.71828 to the 4th power. That's a big number, right? I'm going to subtract 5 from it. Is it going to be positive or negative? Positive, because e to the 4th is going to be a pretty big number. So this is greater than 0. So while you may not be able to find out the exact values, you know whether this is greater than or equal to 0. So I really probably should do this. This is your first step. You got to do continuity. Your second step here is to find the values of the function at those endpoints. Okay? Your third step right here is going to be to say that zeros between these two values, right? So which one of these was negative, f of negative 1 or f of 2? F of negative 1 was our negative one, right? So we're going to say f of negative 1 is less than 0, which is less than f of 2. And then our last thing that we need to do is our conclusion. So we're going to say, by the intermediate value theorem, f of x equals 0 at least once on the interval from negative 1 to 2. I think this is enough. Like, they're going to give you that probably. If you want to be very clear, you can say, therefore, f has at least 1 0. On negative 1, 2. So this is one thing that you might be asked to do. And if it's on for response, it's got to include all those parts, right? You've got to always start with continuity. If it's not continuous, then you can't use intermediate value theorem. Then you're going to find function at the endpoints. You're going to show that the number you're concerned with is between those 2 points, and then make your conclusion using the intermediate value theorem. Okay? Let's move on. All right, this is very similar, but a little bit different, because this time they're not asking us for the excuse me. They're not asking us for the zeros. They're saying there is some c such that f of c equals -3. So this time, if we kind of picture what we're talking about on Desmos, we got that function f of x equals, what was it? X squared minus 9 over x minus 5. Okay, so that's this equation. They are asking us, this has a discontinuity, right? We're looking at, like, you got a vertical asymptote. Where is the vertical asymptote? At 5. But what's the interval they asked us to look at? -1 to 4. Does that include 5? It does not. So we could say something like f is continuous everywhere except at x equals 5. So if that's true, so f is continuous on the interval from -1 to 4. Right, so that's your first step. Always got to say continuity. Okay, so the second thing that we're going to do is we've got to see, so if f is continuous, we need to know what f of -1 is and what f of 4 is. So this is our second step, f of -1 is going to be -1 squared minus 9 over -1 minus 5, which is 1 minus 9 over -6. So -8 over -6, which is positive 4/3 there. We also need to find f of 4. So that's going to be 4 squared minus 9 over 4 minus 5, which is going to give us 16 minus 9 over -1. Which is 7 over -1, so -7. What number do we need to be in the middle of those two? -3. Is -3 between 4/3 and -7? It is. Now, be careful how you write this in your next step. So your next step, your third step here, is that you need to say -3 is between these two numbers. Which one needs to go first? What's the lowest? That -7. And so I would say f of 4 is less than -3, which is less than f of -1. It's not always your lowest like x value that you're plugging in. Sometimes it's the other way around. So put your lowest one first, less than -3, less than f of -1. It's also important here, if you're using f of notation here, that you labeled this over here. You can't leave off that f of -1 because then it's just a bunch of scratch work and you have no proof that f of 4 is actually less than -3. So make sure you label things carefully. And then once you have this, you can make your conclusion by the intermediate value theorem. And then here's my advice to you. The question says, prove that the function f shown below, it should say, prove that for the function f shown below, there is some c such that f of c equals -3. Just reword that. Like you're stating, they're asking you to prove this, so say, here it is, I have proven, reword it. So just say, on the interval -1, 4. We don't need to say prove that the function f because that's what they were telling us to do. On the interval from -1 to 4, there is some c such that f of c equals -3. So sometimes I have a hard time like rewording things. I feel like I've left something out. But if you just take the question they gave you and like write it back like they said, it will be a good last statement on these. Okay, questions? Okay, let's look at a few other things. These are similar to what you're going to see on free response questions. Here, let's look at what a multiple choice might look like for this. Okay. I didn't put a calculator on this slide. Is that because I forgot, or because it's not calculator active? Let's try to do it without a calculator and we shall see. We may give up and I might be like, this was supposed to be calculator active. So they give us a function f. The intermediate value theorem applied to f on the closed interval from -9 to 4 guarantees a solution in -9 to 4 to which of the following equations? Okay. So basically we're saying like f of c has to equal which one of these, right? It's telling us the intermediate value theorem applies, so even if we don't know if this is continuous, it's telling us that it does apply, so it has to be continuous. You don't have to think too hard about that. Intermediate value theorem, I would need to find f of -9 and f of 4, and then those would be like my upper and lower limits, and then f of c has to equal something in between them, right? So let's see if I can get an idea here. If I do f of -9, I will have -9 plus cosine of -9 over 5 minus 3. And then if I do f of 4, we'll get 4 plus cosine of 4 over 5 minus 3. I could see this going either way. It's a little bit easier if it's calculator active question. If it's a calculator active question, you just plug in and get the exact numbers for these. Maybe it might not be calculator active. So if it's not calculator active, right here, I could put the negative 9 and the negative 3 together. So I got negative 12 plus cosine of negative 9 over 5. What is the biggest cosine could be? The very biggest cosine of anything could be. The biggest it could be is 1. The lowest it could be is negative 1. So like this right here could be negative 12 plus 1, which would give us negative 11. It also could be negative 12 minus 1, which would give us negative 13. I don't know exactly the value, but it's got to be between negative 11 and negative 13. Which answer choice would that? Well, actually, no, we need to know the other part first. Okay, so this is somewhere between negative 11 and negative 13. Let's think about the same thing here. 4 minus 3 would give us 1 plus cosine of 4/5. Right? So again, cosine, the very biggest it could be is 1. The very smallest it would be was negative 1. So this is 1 plus 1 would be 2. It could be as big as 2. It also could be 1 minus 1, which is 0. So I know f of 4 is between 0 and 2. Now, which ones can I definitely rule out from this? Okay, A is out because we're talking about, like, if we think about the number line, like, here's 0, here's, oh wait, 0 is over here. Actually, I need 2. Let's start that over. If we think about the number line, like, here is negative 13, there's negative 11, here's 0, here's 2. I know that I got some number somewhere right here. I got another one about right here. But I know negative 20 is way down here, so that's not going to work. I also know 9 is way up here. That's not going to work. So if I think about this a little bit more, in order to get 1, I'd have to have cosine of pi over 2, right? It's 4/5 pi over 2. It is not. So is it going to actually be 2? It is not. It's going to be a little bit less than 2, right? So it's not going to be this. Same thing for the 0. It's not going to actually be 0 because for you to get 0 here, it would have to be like 0 or pi, and it's not. So it's going to be a little bit bigger than 0. So you've got a number down here and a number up here. 0 is going to have to be between it. 2 is not necessarily, so it would be B. If this is calculator active, it's much easier because you get exact numbers. It's the same process, though. You get like a lower number and a higher number, and you're looking for the one that's in between. Okay, questions there? All right, another multiple choice. Let f be a function such that f of negative 3 is less than 9, less than f of 6. Which of the following statements provides sufficient additional information to conclude that there is a value x equals c in the interval from negative 3 to 6 such that f of c equals 9? Okay. What do you guys think? Okay, it's got to be C. C is it. Because that's essentially intermediate value theorem, right? They're telling you that f of -3 is less than 9, less than f of 6, which means on the interval from -3 to 6, you know that this like left point is lower than the right point. And it's saying that it's got to cross 9, right? In order for that to be the case, f has to be continuous. A function can be increasing and have a vertical asymptote, or a jump. It can be decreasing and have a vertical asymptote or a jump. That is not going to help. This having a value where you get f of x equals 6, that's just like random answer trying to throw you off there. But the condition you have to have for any intermediate value theorem is that f has to be continuous. Notice this doesn't actually say intermediate value theorem anywhere, but it's what's being applied in this case. All right, questions there? All right, I think we've got one more to look at. Okay, so here we got on the interval from 0 to 4, the function f shown below must have a value x equals c such that either f of c equals -5, f of c equals 2, f of c equals 6, or no value can be determined. So, ideas. Very good. So Molly has caught this right away. What a lot of students do is they find f of 0, and then they find f of 4. And they're like, oh, 2 is between that. It's got to be the answer. But what we've got to look at first, what we always have to look at first for an intermediate value theorem sort of problem is continuity. And we have, in this case, that this is discontinuous. At x equals 2, and 2 is on the interval from 0 to 4. So if we have a function that's discontinuous, we cannot determine what that c value would be, so D would have to be the answer for that. If this were continuous on our interval, then we would do like we did on example 3, and we would find f of 0, f of 4, and then we see which one falls in between those values. But that didn't happen for us here. Okay, questions? All right, we have about 10 minutes, so you can get started on this right here. On page 97, you are going to do 89 through 92, and let's see, 89 through 92. These are asking for zeros, so it is like that first example that we did. Technically, it's Rolle's theorem, but you can use intermediate value theorem for it. And then 99 through 102, you're proving that using intermediate value theorem for those there. These are a little bit different. Because they ask you to prove, on 99, it asks you to prove and it asks you to find C. I should have done one of those. So like 99, you would say f of x is continuous because it's quadratic. And then you would find like f of 0 equals 0 squared plus 0 minus 1, which is -1. You would find f of 5 equals 5 squared plus 5 minus 1, which is 25 plus 5 minus 1, which will give you 29. The question is asking about f of c equals 11. 11 is between f of 0 and f of 5, so you would say f of 0 is less than 11, less than f of 5. Therefore, by intermediate value theorem, there must be some C on the interval um, 0 to 5 such that f of c equals 11. That's the part where you are verifying that this has to happen. This also asks you to find the c value that makes it true. And let me see what the answers look like on that. Even though it doesn't give you that as it says find the value of C guaranteed by the intermediate value theorem, but then on the answers it doesn't actually do that. Oh, it does. I see right there. So then what you would be doing, like 11 is your, so for that second part, 11 is your y coordinate. So you would be plugging it in for the y. You would say x squared plus x minus 1 equals 11. So you're finding where that equals 1. These are all whole numbers. How do I solve that without using the calculator? How do you solve a quadratic? Everything to one side. X squared plus x minus 12 equals 0. Factor it. You're going to get a plus 4, a minus 3. You get x equals negative 4 and x equals 3. But for this interval, what's the only one that works? 3, because it's the only one between 0 and 5. So C equals 3. So it's wanting you to go to a step further and find what that value would equal. And all you're going to do for that is take your function and set it equal to the y value for that. Let me see if I can do that so you can see the whole thing. If you get desperate on solving those for the C on those last 4, if you do it with Desmos, that's okay. But they are all whole numbers, so I think they're ones that you can solve by hand if you remember how to solve them by hand. 101 might be real bad, though. It might be synthetic division. I don't know if we know that or not. If you have to graph it, it's okay. Mm-hmm.
You want like a full explanation on the 9292?
Yes, please.
Okay.
Yeah. It's kind of a pain. I will agree it's kind of a pain. These are not my favorite problems to do. But that repetitive practice of saying it over and over again will make you remember the pieces you have to have if you see it on the free response section, because this shows up on the free response section fairly often, like on the real test.